Hello, everyone. My name is Astra, and I'll be your trainer from VS Tech Horizon. In this video, we're diving into the most fascinating part of robotics, the brain of the robot, called controllers. Just like how our brain controls everything we do, controllers act as the brains of robots. Ready to explore? Let's get started. Before we get into the details, let's understand how robots think and act. Robots rely on their brain, the controller, to process information from their sensors and decide what to do next. Without controllers, robots wouldn't be able to perform tasks. So, what exactly is a controller? It's a small device that controls the robot by processing signals from sensors and sending commands to other components, like motors and LEDs. It's the core of any robot, helping it think and act. Here's a closer look at an Arduino Uno, a popular microcontroller used in robotics. It's like the robot's brain. Let's watch a short video to see all the components on this board and how they're placed. Now, let's compare this to how the human body works. Just like our brain receives information from our senses and sends signals to our muscles, a controller does the same for a robot. When you touch something hot, your brain processes it quickly and tells your hand to pull away. A robot's controller works similarly. There are many types of controllers, each suited for different purposes. Here are some examples. Arduino Uno and Nano, great for beginners and small projects. Raspberry Pi, a powerful computer-like controller. ESP32, perfect for advanced IoT projects. Each has its unique strengths, but they all help robots think and act. Let's understand how a controller works. Think of it as the decision maker in a robot. It takes input from sensors, processes the data, and gives commands to make the robot perform a specific task. For example, if a robot has to move when it senses an object, the controller processes the sensor data and sends a signal to the motors to move. Controllers act like the robot's brain. Now, let's see this in action. When an IR sensor detects a hand nearby, the controller processes this signal and tells the LED to turn on. This is done using an Arduino Nano. It's a simple project that shows how sensors and controllers work together to make a robot smart. Why are controllers so important? Without them, robots wouldn't know what to do. Let me show you the difference. First, we'll see a simple robot called a Bristol bot that works without a controller. It's basic and can only perform limited actions. But when we use a controller, like in this line-following robot, it becomes smarter and can perform complex tasks. Here's a diagram of how a line-following robot works. The controller takes inputs from sensors that detect the line and sends commands to the motors to move the robot along the path. It's a great example of how controllers make robots smarter and more efficient. Here's how the code behind a line-following robot works. The microcontroller reads sensor inputs to detect the line's position. If the left sensor detects the line, the robot turns left. If the right sensor detects it, it turns right. When both sensors detect the line, it moves forward. The motor control logic ensures smooth movement, and advanced versions use a PID controller for better accuracy. This allows the robot to autonomously follow the path in real time. In our next session, we'll dive into sensors and components, the parts that allow robots to sense the world around them. We'll explore how sensors like IR, ultrasonic, and temperature sensors work, along with other important components like motors and power sources. Get ready to learn more about building your own robot.